Okay, thank you. We are done writing, let me know.
Yes, sir. Okay, done, sir.
Okay. Now that we have determined the critical numbers or critical values, we will now go and use sign table to determine where the gradient curve or graph will be above the x-axis or below the x-axis by using sign table. But before we go into that, let me quickly go over this again. We have to sketch the graph. I have omitted something here. Sketch the graph. Please put graph here of f prime of x, given that f of x is x cubed minus 3x. So the first thing we'll do is to differentiate f of x given to obtain f prime of x, which is 3x squared minus 3. Then find the critical number by equating the derivative to 0. And that's what I mean by at turning point or at stationary point. F prime of x is 0. So we do that to obtain two values of x. Now, a pitfall. You must be careful when you want to solve this. Let me use red pen to show you the pitfall. The pitfall is this. You know what we have is, we said 3x squared minus 3 equals 0. It is possible for you to go and say 3x squared equals 3. 3 divided by 3, 1. X squared equals 1. And you now say x equals square root of 1, which is 1. If you do that, you are saying you only have one value, only one critical number, which is pretty wrong. I've told you severally, anytime you are finding square root, it must be plus or minus, except when you have special condition attached to the question. Do you get that now? That will let us know, okay, the examiner is actually interested in only positive value. So anytime you are finding square root and no condition is attached, you say it is plus or minus. Take note of that. Is that clear?
Yes, sir.
Okay. So we've obtained the critical numbers to be minus 1 and 1. Now, my comment here now says the point where the gradient curve will intercept the x-axis. That's our critical value. So that's where we're going to start from if you want to sketch. But before that, let's move on. So let's now determine where the curve will be above and where it will be below the x-axis. So you do that by using sign table. Sorry, let me change the color back to black. So we are using sine table now. As the name implies, we are only interested in the sign. So I want to put in the critical numbers -1, 1. You always arrange it in ascending order like that, from left to right. Now here, to the right of 1, numbers that are there are greater than 1. To the left of 1, numbers that are there are less than 1. To the right of -1, numbers that are there are greater than -1. So I have here s greater than -1, but less than 1. Then to the left of -1, numbers that are there are less than -1. So I have here s less than -1. Now, I will now get my test value. Then f prime of x, I want to see how it's going to behave. And s prime of x is 3s squared minus 3. Is that clear?
Yes, sir.
Okay. Now, for this one, we need a number that is less than -1. And of course, you know, if you draw your number line, 0, 1, 2, -1, -2. And this is the increasing order. So number that is less than -1, you can take -2. We are using
Alright.
as our test value.
Yeah.
Here, we can use 0 as our test value. Here, you can take 2 as our test value. Now, let's substitute -2 here. If you substitute -2 into 3s squared minus 3, will it give us positive value or negative value?
Give us positive value.
Positive value. If you substitute 0 here,
It gives us a negative value.
very good. If you substitute 2 here, it gives us
Positive value.
very good. So you can see that positive means that it's increasing here. Or you want to say f prime is above x-axis because the derivative is positive. That means it's increasing at that point. F prime of x is above the x-axis. Now, where we have negative, it means f prime of x is below x-axis. Then here is also positive, so f prime of x is above the x-axis. So copy that. Now you can see that what we have here is synonymous to increasing and decreasing function that we have discussed earlier. Increasing and decreasing function. Remember that. If you are to be just to determine the interval in which it is increasing or decreasing, the plus there will say is an increasing function in the interval -infinity to -1. Decreasing from -1 to 1. Increasing from +1 to +infinity. Hope that is clear.
Yes, sir.
Yeah. So it's the same concept. So please put up this table. When you are done with that, let me know. Then we'll now sketch it.
Yes, sir.
You should be sure writing that.
Sir.
You're done.
Yes, sir.
Okay. So let me sketch that for you to explain what we mean by above and below there. Then I will now show you from the graphing utility. Let me use a straight line here. So you have x-axis, y-axis, origin. So let's assume -1 is here. And let's assume 1 is here. Now, if I'm putting this up in a graphing utility, I mean, graph book, of course, I'm going to count correct interval. Now, these are critical points. Now, let's go back to our sign table. We said less than 1. At that point, the line is above f prime of x is above the x-axis. So that means, no, before this one, let me go to where we obtain the critical number. I said the critical number of values are x equals to -1 and x equals 1. The point where the gradient curve will intersect the x-axis. So that means we are going to have an intercept here where I put -1 and 1. So we have a point here. So the curve is going to pass through this point. Is that clear?
Yes, sir.
Let me use red. Let me use red so that you will get what I'm trying to do. So it will pass through this point, pass through this point. So from the table, from the sign table, we now said that for less than 1, f prime is above. So that means we're going to have line above here. Then greater than 1, f prime is also above. So to be above here. All right? Now between -1 and 1, we said is negative. So it's going to be below the x-axis. So we're going to have the curve coming below here. Can you see that? So this is the graph of y equals f prime of x. This is the graph of f prime of x. Am I communicating?
Yes, sir.
Okay. So please sketch it. Hope you can you see the logic that I've used?
Yes, sir.
Yeah. So sketch that. When you are done, let me know. I will now show you the original graph and the derivative from graphing utility.
You're drawing it, sir.
Okay. So let me now share my graphing utility with you now. Please approve for me to share screen. Yes. Can you see the screen? You can see the graph now. Can you see it?
Yes, sir. I can see it.
Now, the blue is the graph of f of s. That's s cubed minus 3s. So you can see it's sinusoidal in nature. Then the derivative is the red, which is 3s squared minus 3. So you can see that it has s-intercept at -1 here and here +1. So where the red line crosses the x-axis, that's -1 and 1. Is that clear?
Yes, sir.
All right. So let's go back to our board. So let me now give you one to do. Sketch the gradient graph for the function f of x equals
Wait, so can you quickly show your what is it? What is it? The FX one, the F inverse of X for the previous one. The what is it? The that equation for the graph.
this.
No, because you showed one that it went up, down, up. Or was that just the F of X?
This
That
this is
was
f prime of x.
oh, okay.
Or the one I showed you from the graphing utility.
Oh no, okay, no, I understand now. Sorry. I understand. I got confused a bit. Sorry.
Okay. Can I move on? Should I move on?
Yes, sir.
So sketch the gradient graph. The gradient graph for the function f of x equals x raised to power 2 minus 4x plus 3. So do that quickly.
So I don't need to do any differentiation. I just have to do drawing, right? Just
I don't understand.
I have to differentiate.
Where do we start? Look at the example. Are you
Oh,
writing
you
it
did
down?
differentiate it. Yes, sir. I'm writing it now.
You start by
Yeah,
differentiating.
you did differentiate. Yeah.
After that, you find the critical numbers from the turning point.
Lisa.
I'm with you.
So
Are
I
you? I
got
said
what
you
is
should
it?
do it.
When X yeah, no. So what I got when X is less than two, it's positive, and when X is greater than two, it's positive as well. So the turning point's above the X, it doesn't intersect the X axis.
So
Correct? Is
how
that
does the
correct?
graph look like?
So it's above the X axis.
And how does the
Can I
graph
do it?
look like? It's above the x-axis. Is it a curve or is
Yeah,
it?
it's a what is it? It's a curve.
Mm. Are you sure?
Okay.
Are you sure? Are you sure it's going to be a curve? What's your derivative?
2x minus 4.
Okay. So f prime of x is 2x minus 4, correct? F prime of minus x, I mean f prime of x equals 0 at turning point. 2x minus 4 is 0. X, 2x equals 4, x equals 2. So we have only one critical number, isn't it?
Yes, sir.
Okay. Can we do sign table for that? Only one critical number, 2. To the right of 2, numbers that are greater than it.
It's
To its
positive.
left, less than 2, isn't it?
Yes, sir.
Okay. Now let's take test value,
They're both positive. When it's less or above x, 2 is positive.
positive. Okay. So what does that connote? So if you take less than 2, wait, let's see, take less than 2. Maybe you want to take 1. Here you want to take 3. So if you substitute 1 here, that will give me negative, isn't it?
Yes, sir.
So if it is negative, what would that be? Below x-axis.
Yes, sir.
But you say both are above. Now if I take 3, substitute 3 here, it's going to be positive. So here it's going to be above x-axis. Now we have only one critical number, x, y. So critical number is 2. Let's suppose 2 is here. So this is x-intercept. Numbers that are less than 2, they are to the left. The line is going to be below. So the line will be here. Hope I'm communicating. Numbers that are greater than 2, they are to the right. It will be above here. This is the graph of f prime of x. So it's a straight line.
Wait,
It's
sir, no, sir. Should it not be, was when x is less than 2, should it not be above the x-axis? So if you use 0, you get
no, no, no,
plus
no.
3.
Less than 2. Even if you use 0, it's going to be negative. What do you say negative is? Let's go back to the table above here.
Oh, wait, 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 do you put it into the original equation or no?
Oh, wait,
Wait.
wait, wait. When it is negative, we said it's going to be below, isn't it? You are
Yeah,
substituting
no. Yeah,
into
no,
your derivative.
I substituted, no. So what I'm saying, I substituted a number less than 2 to
Yes.
0. So I use the x, or do I use the equation x squared minus 4x plus 3, or do I use the 2x minus 4?
You are using the derivative function,
Oh, okay, yeah,
x
then,
minus 4.
okay, then, yeah, so it's negative then.
And that is why, look at it. Look at the table prior to this one. That is why I put this there. Can you see? We are substituting
Oh, yeah.
of the derivative. not f of s.
Okay.
All right. So you can see that it's going to be a straight line. That's the gradient graph. Does that make sense to you?
Yes, sir.
Okay. When you are done with that, let me know so I can give you another one.
Hello, sir.
I'm with you. Are you done?
Oh yeah, yeah.
I said when you are done, let me know.
Oh, sorry.
Okay. Let me give you another one. Sketch the gradient graph of f of s equals s raised to the power 4 minus 4s squared. So do that quickly. Hope you are making progress.
Yes, I am. Okay, done, sir.
Okay, what did you get?
So for the what is it? For the sine table, I got negative, negative, positive.
No, that's not what I want to hear.
So then the graph, wait,
Wait. Start by telling me what the derivative is.
4x cubed minus 8x.
Okay? The critical numbers.
So plus or minus 2.
Only, you're supposed to get three critical numbers. Three. Look at this. Your derivative is 4s cubed.
Oh, okay. I see what I've gone wrong. Sorry, my bad.
Uh-huh.
Hold on.
So this should be 4s cubed minus 8x equals 0. Factor out 4x. Factor out 4x. So that gives you s squared minus 2 equals 0. So 4x equals 0 or s squared minus 2 equals 0. That's the standard way of going. If you just take one of the parameters to the right, you are going to get one. That was what I emphasized for you here. I think okay, maybe I've cleaned it. I don't know. Let me go and check. Oh, I think I've cleaned it. I emphasized it for you when I wrote it in red. Do you get that now? So you must be careful. Work it out in a standard way. This is a standard way. So this is part of the solution. S equals 0 here. When 4s is 0, so s is 0. Then here, x equals plus or minus root 2. Therefore, the critical numbers are minus root 2, 0, root 2. I decided to arrange it for you in ascending order. Is that clear? So
Yes,
these
sir.
are my critical numbers. It is with this now, I will now go and put up sine table. Minus root 2, 0, root 2. To the right of root 2, you have them to be greater than it. To the left of root 2, you have less. To the right of 0, you have greater than 0. To the left of 0, you have less than 0. Here you have greater than minus 2, minus root 2. Here you have less than minus root 2. So test value then f prime of x. So what's our f prime now? We are using the original derivative, which is 4x cubed minus 8x. 4x cubed minus 8x. Okay? So first of all, pick the test values. Now, don't forget that root 2 here means 1.41. If you want to view it in decimal, so that your work will be easier. All right?
Okay.
So pick a number that is less than minus 1.41,
-2.
maybe minus 2. Okay? So if you substitute minus 2 here, let's say minus 2, let's take the test value first. Pick a number that is greater than
-1.
minus 1. Here, greater than 0, less than
Uh,
1.2, maybe 1.
1.
Here, 2.
Yes.
So one by one, substitute them here. I think this is going to give us what? Negative.
Negative.
So if it is negative,
Positive.
this one is going to be positive. Are you sure?
Yep.
Minus 4 plus, okay, positive. Yes. If it is 1,
Negative.
negative. If it is
Positive.
2, positive. So below, below x, above x, let me put axis there so that to be clear. Below x axis, then above x axis. So copy the sign table. Or do you need to copy this one?
I need to copy the one on
Okay.
the board.
Copy this quickly.
I already got that above the it's just a
Okay.
sign table.
So copy the sign table now.
Yeah, think so.
Okay. So can you now sketch? So you go and identify those critical numbers. So how many of them? 3.
Four. It's 1, 2, 3, 4.
So let's suppose minus 1.41 is here, 0, 1.41 here. So when you have the point here, you have it here. Okay, let me use red for that. Or black. You have it here, you have it here, you have it here. So from the sine table, we said the line is going to be below. So the line is going to be below. You're going to have this. Then from minus root 2 to 0 is going to be above. Minus root 2 to 0 is going to be above. So the line will come this way. Can you see that?
Yes, sir.
Then from 0 to root 2, that's 0 to 1.41, is going to be below again. So we are going to have it here. Then above. So you can see the graph now. So this is f prime of x. F prime of x. So sketch that quickly. Hope you get the pattern in which we move. So your guide is the sign table. It's important anytime you want to solve problem, make sure you do the sign table. Failure to do the sign table will not help you. Am I communicating?
Yes, sir. Okay, done, sir.
Okay. So this is where we'll continue next week. I mean, this Saturday, right?
Yes, sir.
Bye.
Bye. Have a good day.
You too.